Hey everyone, in today's video we're going to be doing another measurement to measurement conversion, this time meters to inches. So the problem at hand is this. A typical cesium atom has a diameter of about 300 picometers. They've even gone so far to tell you that pico is times 10 to the minus 10. Okay, part A asks, what is this in inches? And part B, approximately how many cesium atoms are there along a 2 centimeter line? Okay, so starting with part A, converting meters to inches. Now this is simply a unit to unit conversion. And you can use the strategy I'm about to show you for any unit to unit conversion. It always works, just like I showed you in the previous video. Okay. So the first step is always the same. You write what you're given. Okay, so in this question we're given the diameter of a cesium atom. So I'm going to give that the label D for diameter, subscript C for cesium. Okay, it's 300 picometers. Okay, you want to go ahead and write that exactly as it is, as just a number. So remove the prefix. Okay, so that becomes 300 times 10 to the minus 10 meters. Okay, the next line is, what are you looking for? Okay, so DC in inches equals question mark. The line after that is then the mathematical statement that connects this unit to this unit. Okay, so that turns out to be 39.37 inches is equal to 1 meter. Okay, so again, same process for all the questions. Write down what you're given, write down what you're looking for, write down the mathematical statement that connects the unit here with the unit here. Okay, the next step, also the same for all conversions. Okay, so you take what you're given, which in this case is 300 times 10 to the minus 10 meters, and you multiply by 1. Now, if you watch the previous conversion video, you'll know why I'm multiplying by 1. Otherwise, you're probably sitting there wondering, why am I multiplying by 1? Okay. Well, I'm going to give you two reasons. Okay, first, if I multiply by any other number, I'm going to change the original question. Now, you might be sitting there saying, well, of course. I mean, yeah, I think that was going without saying, but why multiply by 1? Okay, why multiply by 1 at all? Okay, so the idea is this. This 1 is how you change the unit. Okay, so the first thing you got to think about is, well, how do I rewrite 1 in a few different ways? Okay, so if I could write 1 as a fraction, I could write it as 3 over 3. I could write it as 7 over 7. Okay, why? Because the top and the bottom are equal to each other. But take this on for size. 100 centimeters over 1 meter. Okay, this ratio is still equal to 1 because 100 centimeters is equal to a meter. Okay, in this case, we're actually told 39.37 inches is equal to a meter. So this is how we can rewrite 1. Okay, so 1 can be rewritten as 39.37 inches over 1 meter. And it can also be rewritten as 1 meter over 39.37 inches. Okay, so we're going to be using one of these two for our problem here because this is the one that matters. Okay, the question is, which one do you use? Okay, so before we get to that, let's write down the next step. Okay, 300 times 10 to the minus 10 meters. Do not drop that unit. It's very important that you keep it. Now you replace the times 1 with a big bracket and you draw a line down the middle. It's pretty much an empty fraction that you're going to fill out in a second. Okay, now this is where you have to question yourself. You have meters here. You're trying to get rid of meters. Now, you don't get rid of meters by multiplying meters by meters, right? Meters times meters equals meters squared. But meters divided by meters will disappear. Okay, so therefore I need to write meters in the bottom. The unit that I'm trying to achieve is inches, so I write that on top. And the ratio of inches to meters that equals 1 is this one right here. Okay, so that's the one I'm going to plug in. 39.37 inches is 1 meter. Okay, and this becomes very convenient because watch, the meters just cancel out, and the only unit you're left with is inches. Okay, so let's see, there we go. Okay, so if you go ahead and do 300 times 39.37 inches, you're going to end up with the following number. 1.1811 times 10 to the minus 6 inches. Okay. At this point, you have to say, okay, well, that's the answer almost. You have to make sure this is correct to the number of sig figs. So you go back to your original question and you're given 1 sig fig here. Remember, your answer can only be as, well, certain as what's been given to you in the problem. So we've got to round our answer to 1 sig fig, right? So if you round this to 1 sig fig, you're going to get 1 times 10 to the minus 6 inches. And there is your answer for part A. Simple as that. Okay, part B, let's remember what part B was. Okay. Approximately how many cesium atoms are there along a 2 centimeter line? Okay, so you're probably used to doing enough physics problems and math problems at this point that usually when the question is divided into parts A, B, C, etc., usually A helps you get B, which helps you get C. And generally speaking, that is the case, except in this question. Okay, if you didn't realize already, it's asking about how many cesium atoms there are along a 2 centimeter line. The original question also gives it to you in a form of meters, okay, picometers. Okay, so both these values are given in terms of the metric system, so you don't need to use inches to find out how many cesium atoms fits in a 2 centimeter line. It's just going to cause more work. You can do it if you'd like, but, you know, I wouldn't recommend it. Okay, so part B, visualize the problem as such. Okay, so you've got a 2 centimeter line, and let's say 1 cesium atom takes up that much space. Okay, so we are given in the problem that each cesium atom has a diameter of 300 picometers. Okay, so that's 300 times 10 to the minus 10 meters. And we're trying to figure out, well, how many can we fit? Yeah, obviously this diagram is not to scale, but you get the idea, right? How many can we fit along that line? So there's only one thing we got to do, and that's convert the centimeters to the unit of meters. Okay, so let's go ahead and do that. You should already be an expert on doing this, and if not, well, here's how you do it once again. You've got the 2 centimeters. You multiply that by 1, okay, equals 2 centimeters times. Replace the 1 with a large bracket, draw a line in the middle. Okay. You're trying to get rid of centimeters, so centimeters goes on the bottom. You're trying to achieve the unit of meters, so meters goes on top. Now the ratio of meters to centimeters, which equals 1, is 1 meter over 100 centimeters. Okay, so doing that cancels out your meter unit, your centimeter unit. So you're left with 2 divided by 100, which is 0.020 meters. Okay, if you're used to the metric system, you probably could have just done that in your head. And if you're not used to it, don't sweat it. Okay, you just gotta practice doing it like this. And again, this works for every single scenario, as I just showed you. Okay, so this is how wide the total length is. We know how wide, which is the diameter of the cesium atom. Let's figure out how many we can fit. Okay, so let's do that on this side. So the number of cesium atoms is equal to the total width of the line, or the length of the line, 0.020 meters, divided by how much space each one takes up, which turns out to be the diameter of the cesium atom, 300 times 10 to the minus 10 meters. Okay, you know that you've done this right because you're trying to get a number out, therefore this is a unitless quantity. Okay, on the right, your meters cancel out, leaving you unitless, which is exactly what you're trying to get. Okay, so if you go ahead and divide those two numbers, you're going to get 666.6667 cesium atoms. But, well, here's the thing, you probably realized this yourself. You cannot fit 2/3 of an atom. Okay, even though that's probably empty space, the other one's empty space, an entire atom, you still can't, logically have 2/3 of an atom. So this would technically get rounded to 666,666 atoms. But then there's one more thing you got to consider. Again, it's those sig figs again. Okay, remember the original question has 1 sig fig, therefore your answer must also have 1. Okay, so 666, 666, rounded to 1 sig fig is 7 times 10 to the 5. Okay, so this is how many cesium atoms can fit along a 2 centimeter line, thereby answering part B. Okay, so that's it for this video, guys. If you enjoyed it, be sure to give that like button a click. Subscribe to this channel so you never miss a video from me. Thank you so much for watching.